Good evening. Thank you for joining me. In this live stream, I'm going to be introducing the idea of arrays and using them with loops inside of Java. Up till now, we've been dealing with things like strings, which are actually a linear collection of characters, and now we're going to introduce the idea of an array, which is a linear collection of pretty much whatever you want. So an array, like I said, is a linear collection of storage elements. You can think of them as being kind of like boxes where you can put things into the box and you can take things out of the box. But the idea is that instead of having, let's say, 4 individual variables that holds 4 numbers, you can have an array of numbers held under one single name. Like here I've got an array called ages that holds 4 integers, 5, 8, 1, and 6. And down here I've got an array called greetings that holds 5 strings, 1, 2, 3, 4, 5. Just so happens the 5th one here is empty, so there's nothing stored in the 5th one. All right, so rather than having 4 individual variables to hold each of these 4 numbers, I can have one variable called ages, and then I can hold all 4 numbers together in one place. Now, the length of each of these arrays is dependent upon how many boxes there are. So we can say ages.length is 4 here because there's 4 boxes, and greetings.length is 5 because there's 5 boxes, and even though one of the boxes is empty, the length of this is still 5 because there's 1, 2, 3, 4, 5 things here. If you want to refer to each individual item in the array, then you need to know how to access each of the elements. And in arrays, they are indexed. And in Java, the indexes start at 0. So what we think of as being the first box is really the 0th box. Then there's 1, 2, and 3 for this one. And then for the greetings array, there's 0, 1, 2, 3, and 4. Now, the thing to notice here is since the array indices always start at 0, the highest index is 1 less than the length. So if the length is 4, the highest index is going to be 3. If the length is 5, the highest index is going to be 4. This is always true of all arrays in Java. The next thing you'd want to know is, how do I access each one of these elements of the array? So for example, if I want to access this number 1 sitting here, I need to know the box number, the element number, so that's going to be number 2. So what I write here is ages, and then I use the square brackets, and I put the box number in there. And so this is going to yield a 1. And if I say ages bracket 0, that's going to be a 5. Okay, makes sense so far. If I say greetings bracket 3, that'll be this string. And greetings bracket 4, now depending upon what's actually stored in that box, it could just be the empty string, 2 double quotes, could also be the value null, indicating that actually nothing is stored in there at all. These two actually are different things. This is the absence of any string at all being stored in that box. And this is the empty string. It's a string, but it has nothing in it. It's a string of length 0. So before we show some actual coding examples, one of the things that you might want to do is I want to look at the last element of the array. If I don't even know the element number, if I don't even know the length, how can I look at the last element? And so what you can do is use the fact that you can ask the array how long it is, and then get that number, subtract 1, and that'll give you the very last element. So if I say ages bracket ages.length minus 1, that'll yield 6, right? And the reason for there is that ages.length is 4. We subtract 1, which gives us 3. So what we're really asking for is what's in box number 3, and that's a 6. Okay, so that's how to access elements of an array. We'll do some coding examples where we show not only how to access elements of array, but also how to assign to them, and also how to create brand new arrays. Okay, so let's switch over to the coding examples. Oops. Over here, there we go. Okay, so most of the examples that I'm going to be showing you come off of the CodingBatcom website. This is a great website, if you don't know about it, to go and just practice doing things like accessing strings, arrays, conditionals, loops, and you can do it either in Java or in Python. They have tons and tons of problems. A lot of the problems also have hints, and there's also tutorial videos on how to get some of the background material. In fact, some of the tutorial videos and pages have a lot of the same stuff that I just showed you a moment ago. So here's the first problem we're going to be doing. This is called first last 6, and the problem description says, given an array of integers, return true if 6 appears as either the first or last element of the array. The array will be length 1 or more. So some examples are, if we are asking we're given this array 1, 2, 6, and is 6 either the first or last? And in that case it is true because it's the last one. 6, 1, 2, 3, that one's true because 6 is the first one. And then 13, 6, 1, 2, 3, that one is false because 6 is not the first or the last one. Okay, so there's essentially 3 cases you have to consider here. The first case is that 6 is the first element. The second case is that 6 is the last element. And the third case is that 6 is neither one of those. So we can very quickly put in an if-else condition here. So if something is true, else if something else is true, and then else. All right, so the first condition is probably going to be if the first element is 6, or if the 0th element is 6. So we say if nums bracket 0 is equal to 6. Okay, so the first element, the 0th element is always, the first element of the array is always the 0th element. So you can just do it like this. So if the first element is a 0, we're going to return true. Else, if the last element, now recall from what I showed you a couple minutes ago, we can find out what the last element is by taking the length of the array, subtracting 1, and then looking in that box. So we're going to say nums bracket nums.length minus 1 is equal to 6, return true, and then if neither of those conditions are true, we're going to return false. Okay, so we got our 3 conditions. If the 0th element is a 6, if the last element is a 6, and if neither of them are a 6, then we're going to return false. So let's try it out. Click on go. Looks like we got all greens over here, so I think that's pretty good. I think what I want to do is I can show you how to shorten this up. So notice that we're returning true if these 2 conditions are true. So we can actually get rid of one of these else ifs by saying if num sub 0 is equal to 6, or num sub nums.length minus 1 is equal to 6. Okay, so I clicked on go, got all greens again, so we know that it all worked. And so what I'm just doing is just connecting those 2 conditions together. And then the last thing I want to show you is how to shorten this up even more. Notice here that I'm saying if this condition is true, return true. Else, return false. So in other words, I'm returning true if the condition is true, and I'm returning false if the condition is false. So why not just return the condition that I'm evaluating? So if this condition evaluates to true, that's what I'm going to return. And if it evaluates to false, that's what I'm going to return. Let's see if it works. Good. We got all greens there. Okay, so what I wanted to show you out of this example was how to access specific elements of an array. Here we're accessing element number 0, and here we are calculating the element we wanted to access. We're asking the array for its length, subtracting 1, and then looking in that box. All right, let's move on to the next one. This one is called sum3. It says, given an array of integers of length 3, return the sum of all the elements. So this one doesn't require any kind of loop at all. We're just simply going to look at box number 0, box number 1, and box number 2 and add them up. So this one is just simply return nums 0 plus nums 1 plus nums 2. We're guaranteed, because of the problem statement, that the array will be of length 3. So we don't have to worry about checking the length. We don't have to worry about what happens if it's too long or too short. It's always going to be exactly the right length. So let's give it a try. We got all greens. So that's a pretty short and sweet problem there. Okay, let's move on to the next one. This one is called sum2. It says, given an array of integers, return the sum of the first 2 elements of the array. If the array is less than 2, if the array length is less than 2, just sum up the elements that exist, returning 0 if the length is 0. So it sounds like we have at least 2 possibilities to consider, maybe 3. One of the possibilities is the length of the array is 2 or more. And then another possibility is the length is well, less than 2. Let me draw a picture of this. Okay. So we're showing here that there's an array 1, 2, 3. That's one of the first examples. Then there's another array that's 1, 1, and there's another array that is 1, 1, 1, 1, 1. So 4 ones. And we're going to return the sum of the first 2 elements of the array. So we want 3 in this case, 2 here, 2 here. But let's see if we can come up with our own examples that aren't these 3, that maybe kind of exercise what we call the edge cases. Like, what if the array just has one thing in it? All right, so the sum of that should be 3. And then the final thing is, what if the array is nothing? I'm just drawing a line there to represent nothing. The sum of that should be 0. Okay, so here's these 3 up here are cases where the array is 2 or more. Here's a case where the array is just 1, and here's a case where the array is 0. So it looks like maybe we need to have 3 cases for this. One case that handles this top 3, one to handle this one, and one to handle this one. Let's give it a try. So if nums.length is greater than or equal to 2, we'll do something. Else, if nums.length is equal to 1, we'll do something. And then the final else handles the length is 0. Okay, so if the length is greater than or equal to 2, we should return nums 0 plus nums 1. And if the length is 1, we'll return nums 0. And if the length is 0, we'll just return 0. Okay, let's click on Go. We got all of them green, so everything worked out. Notice that they test here some conditions, like here's the empty array, here's an array with 1 element in it, here's another array with 1 element in it. So what I want to show you here is what happens if we just do something like this. Return nums 0 plus nums 1. What happens if we just ignore the length of the array and just simply have it return the what's in the 0th box and what's in the first box? We click on Go. Actually, we do get some greens over here, but we've also got some reds, and I don't know why this is freaking out over here. Sorry about that. But these reds here, I'm going to remove that from the screen here, says array index out of bounds exception. And so that happens when the array is too short. So here is an array of just 1 element, and we are trying to access elements 0 and 1, but only element number 0 exists. So you are not allowed, in the Java programming language, you are not allowed to step out of bounds on an array. You can't have an index that is less than 0, and you can't have an index that's more than the number of boxes. So you get this array index out of bounds exception if you attempt to walk off the end of either the left side of the array or the right side of the array. So that's why we needed to lay out these 3 conditions to make sure that we only access the elements of the array that were actually there. All right, let's move on to the next problem. This one is called make pi. Return an array of an integer array of length 3 containing the first 3 digits of pi. So this is the first example of a problem where I'm going to show you how to create an array from scratch. And so here's how you do it. First of all, notice that the return type of this function is integer bracket. So this is a shortcut way of saying that this function is going to return an integer array. And this is essentially the type of variable. A variable can be this type as well. So we can say int bracket, we can call it pi. So this says we got a variable called pi whose type is integer array. Now at this point, we haven't told it how many boxes there are. All we've done is we said there's going to be this name, a variable called pi, that's going to be associated with an array, but the array itself doesn't exist. So the very next thing we do is say pi equals new int bracket 3. Okay, so this says make me a new integer array of length 3. So you put inside the brackets here how many boxes you want. Now they'll be numbered 0, 1, and 2, just like we saw before, but the number you put in there is the length, not the highest number. It's the length. So this says make me an integer array of 3 boxes, and then associate it with this variable called pi whose type is integer array. And then we can go ahead and put the numbers right into the boxes. So we say pi bracket 0, that's the first box, equals 3. Pi bracket 1 is equal to 1. And pi bracket 4 is equal to, pi bracket 2 is equal to 4. So we are putting the number 3 into box number 0, the number 1 into box number 1, and the number 4 into box number 2. And then finally we say return our array back to the caller. And perfect. It worked out just fine. All right, so that's how you create an array like this. You create a variable whose type is int array. That's the way I pronounce it, int array, but it's just int bracket. And then you assign to it new int bracket and then the number of boxes you want. Now you can shorten this if you want. We can bring this over here. We can say int array pi equals new int 3. If we click on go, we'll find that that's perfectly okay. All right, so we can shorten array creation into one step. All right, let's move on to the next one, middle way. In this one, it says, given 2 integer arrays, a and b, each of length 3, return a new array of length 2 containing their middle elements. So in the first example here, we're returning the array consisting of 2 and 5 because 2 is the middle element of the first array and 5 is the middle element of the second one. This one is 7 and 8 because of the 7 here and the 8 here. And this one is 2 and 4 because of the 2 here and the 4 here. Okay, so the first thing we need to do in this function is create an array of length 2 and then fill in the numbers. So we'll say int array, I don't know what to call it. Let's call it ARR equals new int bracket 2 because we want 2 elements in it. And then ARR sub 0 is equal to A bracket 1. That's the middle element, the number 1 element of the A array. And ARR sub 1 is equal to B sub 1. That's going to be the middle element of the B array. And then we'll return that array. Let's try it out. Good. We got all greens over there. Okay, so we made an array of size 2, and then we copied the number 1 element out of A into element number 0, and we copied the value out of the number 1 element of B into the first element, number 1 element of the new array, and then we return that array. All right, let's do another one. This one is called count evens. So you're going to be given an integer array, and you want to count the number of even integers in that array. And there's a hint there that you can use the modulo operator to find out if a number is even. Okay, so this is going to be the first example of combining a loop with an array. Because what we need to do is, let's draw another picture over here. What we need to do is, wait, let me copy down an example here. 2, 1, 2, 3, 4, and I'm going to write the index numbers above it. Like that. So the ones in black are the values, and the things in red are the index numbers. Okay, so what we need to do is we need to count the number of even numbers. So we need to start at the beginning of the array and walk our way to the end, looking at each one of the elements and seeing whether it's even or not. So in this case, this one is even. So we're going to have an accumulator that's keeping track of how many even numbers we've seen. So we've seen 1. That's odd, so we're not going to count that one. That one's even, so we'll go to 2. That one's odd, so we won't count it. And this one is even, so the number is going to be 3. So this one should return a 3 back to the caller. Another example was 2, 2, 0. So this one is even, this one is even, and this one is even. 0 is even. So this is also going to return 3 to the caller. Okay, so let's take a look at how this is going to work. We're going to start at element number 0. So we're going to write a loop that starts at element number 0, and it looks at that element number, in this case 2, figures out whether it's even or not, and if it is, it accumulates a sum. And then it looks at element number 1, 2, 3, and then 4. So we've got to write a loop that goes from 0 up to 4. So let's start with our count and initialize it to 0 because there's going to be as few as 0 even numbers. And then we'll write a loop. Now I'm going to show this to you with a while loop and a for loop. So let's do the while loop first. So we'll go integer I equals 0. This is going to be our iterator variable, our initialization. And then we'll say while I is less than. Now let me switch back over here. So we want it to go from 0 to 4, and recall that the length of this array is 5. So we want to continue doing this loop as long as our counter variable is less than the length. As soon as it becomes equal to the length, then we want to bail out of the loop. So the length of this is 5, which is going to mean we want to continue this loop as long as it's less than 5, or as long as it's less than the length. So the way we write this is nums.length. So as long as I is less than the length, we're going to do a condition here. If nums bracket I modulo 2 is equal to 0. So if after dividing the number by 2 we get a 0, then we know that that number is even and we should increment our count. And then outside of that condition, we're going to increment our iterator variable. And then when we're all done, we'll say return the count. All right, so we're going to initialize our counter to 0. We'll initialize our iteration variable to 0. This is going to be our index number. And then say as long as that index number is less than the length of the array, which is going to be 5 for the longer one, if the number inside of box I divided by 2, if the remainder of that is 0, increment our count. And then regardless of whether that number was even or not, we're going to increment our iteration variable. And then that causes it to go back up here, look again to see whether I is less than the length. So it was 0 at first, now it's going to be 1. Yes, it's still true. So it's going to look in box number 1, look to see whether it's even or not, increment the count if it is, increment the variable, so now it's 2. It's still less than the length. So you see it's going to keep going, and then it's finally going to stop when I becomes 5 at the very bottom of the loop. And it comes back up here and it goes, if 5 is less than 5, it's not. So that becomes false. It jumps out of the loop, and then we return the count that we've accumulated. So let's see if this works. Good. Got all greens there. All right, so that's how you do it with a while loop. And I've shown you that you can combine all the pieces of a while loop into a for loop. You take the initialization, the condition, and the increment, and you put them together into one package. So it looks like this. For int I equals 0, that's the initialization. I is less than nums.length. It's the same condition that we had for the while loop, and then I++. We'll take this out here, and then we'll see if it works. Good. Got all greens. So that's how you do it using a for loop. All right? So this is an example of using a loop with an array to process each one of the elements of the array as we go down and stop when we hit the end of the array. Let's go do more 14. Given an array of integers, return true if the number of ones is greater than the number of fours. All right, so this one is true because there's 2 ones and there's 1 4. This one is false because there's 2 ones and there's 2 fours. They're equal, so the number of ones is not greater than the number of fours, so return false. And this one is true because there's 2 ones and there's 0 fours. So in order to do this problem, what we need to do is walk through the array just like we did in the previous problem, start at the beginning, work our way towards the end, but we need to count how many ones and we need to count how many fours, and then compare the 2 numbers at the end and see whether we should return true or false. Okay, so we're going to need 2 accumulator variables. We'll call this one ones, and we'll call this one fours. And then let's use a for loop here. So we'll go for int I equals 0, I is less than nums.length, I++. So after a while, this becomes muscle memory for writing the loop to go through an array. It pretty much always looks like this. The only thing that might change is the name of your iterator variable. It doesn't have to be I. You can call it whatever you want. And of course, the name of the variable itself, the array itself, is going to change. But pretty much it looks like that template there. Okay, so if nums bracket I is equal to a 1, then we're going to increment ones. And if nums bracket I is equal to a 4, we're going to increment fours. Okay, and I'm using the little technique that I showed you where if there's only one thing to do inside the body of a conditional, then you don't have to put the braces on there. So I've only got one thing to do, which is to increment the variable, so I'm not going to put the braces on this one. And I've only got one thing to do there, which is to increment the fours variable, so I'm not going to put the braces on that one. Then when we're all done with the whole loop, after we've processed the entire array, we're now going to say if ones is greater than fours, return true, else return false. And again, I'm omitting the braces because there's only one thing to do in each case. Let's see if it works. Good. Got all greens there. You're probably looking at this going, well, if this is true, we're returning true, so we could shorten this. We could just say return ones is greater than fours. And I clicked on go. We got all greens, so we know that that one worked as well. All right, so that's basically how to do that problem there. So this is a case of where we have to keep track of how many ones and how many fours we're seeing along the way. The template for walking through the array is pretty much the same. What's different is what we actually do along the way. So we are accumulating how many 1s and how many 4s, and then comparing the answer at the end. Let's go do has 22. Given an array of integers, return true if the array contains a 2 next to a 2 somewhere. So this one is true because there's 2 2s. This one is false because there are no 2s next to 2s. And this one is false because, again, there are no 2s next to 2s. So let's take a first stab at it again. So again, we're going to use our basic walk through the array loop. So for int I is equal to 0, I is less than nums.length, I plus. And then what we need to do is we need to look at the ith element of the array and then the one right next to it, maybe the one right after it. And if both of those are 2s, then we know that we found two 2s next to each other. So we'll say if nums bracket I, oops, we need parentheses here, is equal to a 2, and nums bracket I plus 1, so that would be the one right after it, is also a 2, then actually we could just return true at this point. At this point, we're done. We don't actually have to finish the whole loop. We can just say we found 2 2s, they are right next to each other, so let's just return true. The loop won't even complete. We won't even walk through the rest of the array. We're done at this point. We've found the 2 2s. We don't have to look at the rest of them. Let's try it. What went wrong here? Oh, we forgot to, so if the loop completes and we didn't return true at all, then it must be that there are no 2s next to each other. So if we got all the way through the loop and we never returned out of it, then it must be true that there are no 2s next to each other. So let's try this. All right, so we're probably going to get that flashing red over there. I'm not sure why that's happening, but what we can see here is that it's working most of the time, but we've got some of these array index out of bounds exceptions. And these are happening when it looks like when there's a 2 on the end or something like that. Yeah, it's always happening when there's a 2 on the end. Well, anyway, what's happening here is we're looking at the ith element and the one right after it. But what if the element we're looking at, the ith element, is the last element? Then we're attempting to look at the one that's right after it, and we're not allowed to walk off the end of an array. The solution there is to actually walk through the array and stop right before we get to the last element. The last one we should look at is actually the second to last one, the one right before the last one. So we'll do that by, and it's easy here, you just subtract 1 from the length, and this means we're going to stop when we get to the second to last element. Our loop is going to stop, but it's still going to look at that element and the one right after it. All right, that's all green, so that's good. So let me show you an example of where it was failing before. It was like this one right here, 1, 3, 2. So we were looking at the 1 and the 3, and those are both not 2s, so we look at the next pair. We look at the 3 and the 2, and those both aren't 2s, so we look at the next pair. And so we look at the 2, and we attempt to look at the 1 after it, but it's not there. There is no 1 after it. And that's what that array index out of bounds exception was we were attempting to look at an element that was beyond the end of the array. So what we have to do is say stop looping at 1 less than the length so that the furthest it gets actually is 1 and 3. Over here, 1 and 3. So it looks at this pair and then stops. Okay? And then for an example of here, like we look at the 2 and 2, those are 2s right next to each other, and so we end up returning true, and so that we just bail out of the loop at that point. We return from the function, the loop never finishes, all the variables go away, and we're done, we know our answer. All right, let's do the next one. This one is called sum array. Given an array of integers, return the sum of the elements. Okay. So here's a couple of examples. 1, 2, 3, 4, that sums up to 10. 5 and -6 sums to -1, and 7 sums to 7. So probably going to have to start out with our basic loop through the array for int I equals 0, I is less than nums.length, I plus plus. Okay, we're going to need an accumulator. Let's call it sum. And then we'll say sum plus equals num sub I. And then we'll just return the sum. Okay, I think that looks pretty straightforward. Let's try it. What happened? Oh, I'm missing a brace. Don't know what happened to it. There it goes. So we got all greens. That's good. So this is a very basic, I wanted to show you here a very basic recipe for summing up all of the elements of an array. You need an accumulator, and then you just loop from beginning to end, and you increment the sum as you go, and then you return it when you're done. That's all there is to it. Now this one is called sum together. You're going to be given two arrays, both the same length, and you want to return a new array whose elements are the sums of the corresponding elements. So if we add the 8 and the 3 together, we get 11. If we add the 2 and the 5 together, we get 7. And the 1 and the 5 here gives us 6. So we're going to add together the corresponding elements out of the array, and then we're going to produce the sum. So for this one, we're going to have to create a new array that's the same length as the ones we're given, and then sum the corresponding elements. So let me show you pictorially what we're doing. So if we are given array A, which is 8, 2, and 1, and B, which is 3, 5, and 5, and these are the index numbers up at the top, then we're going to have to create a new array that consists of 3 boxes, same as the length of A and B, and we're going to add 8 and 3 to get 11, 2 and 5 to get 7, and 1 and 5 to get 6. Okay, so we're going to have to walk through the array, and we can use one loop for this because we want to add together elements 0 of A and B, then elements 1 of A and B, and elements 2 of A and B. So we just need one loop to do this. So here's our standard loop, int I equals 0, I is less than a dot length. And it doesn't matter whether we use a dot length or b dot length because the lengths are the same. So we can use either one. Okay, but to do this, we're going to need our accumulator, but in this case our accumulator is a brand new array. So before we start the loop, we'll have to create this array, and I'll call it sum. So we go integer array sum equals new integer array, and how many boxes is this array going to have? Well, if I pass an array whose length is 3, the sum array should also have 3. If I pass arrays of length 4, the sum array should have 4. If I pass it an array of length 1, the sum array should have 1. So the sum array should have as many boxes as are in either the A array or the B array. Remember, they're the same length, so it doesn't matter which one I use. So I'm going to say that the sum array is an integer array with as many boxes as the length of A. Okay, so if A had 3 boxes, the length will be 3, and the new array will also have 3. Okay, so inside my loops, I can say sum bracket I is equal to A bracket I plus B bracket I. So this takes the ith element of A, adds it to the ith element of B, and puts it into the ith element of sum. So we're just, like I showed you in the picture, we're just adding kind of column-wise all the way down. And then we're going to return our sum array. So let's see. Nope, again, missing the brace there. Good, got all greens. So that's exactly what we're looking for. Okay, so this is an example of creating an array whose length is not necessarily known at the time that you write the program. You are calculating the length of the array by using the length of some other array. And just as a kind of a side note here, you don't have to base the length of the array off of some length of some other array. This could be some variable, like you get some input from the user, and then you create a variable, create an array of a size where the variable tells, or the user tells you how long it's going to be. Like maybe you ask the user, like, how many people are going to be playing this game? And if they say 3 people or 4 people are going to be playing the game, then you can create an array of length 4 to be able to put the scores for the 4 players in there. Okay, the last one I want to show you is called multiply shorter. So you're going to be given 2 integer arrays. The second one might be shorter than the first one. And you're going to return a new array whose elements are the products of the corresponding elements of the 2 given arrays. If the second array is shorter than the first array, then I want you to repeat the second array as many times as necessary to make their lengths equal. So here's an example. Let me write these examples down on the screen here. So here's A, 1, 2, 3, 4, 5, and B is 8 and 6. Now notice that B is shorter than A, so I want you to repeat B as many times as necessary so that when you add them, it's not the sum, let's call it the product, so that when you multiply them together, you've got 2 arrays that are now essentially the same length. So this would be 8 here, 12, 24, 24, and 40, because we're multiplying down the columns. Another one is A is 4, 8, 1, and 2. B is 2, 2, 3, 3. And so the product is going to be 8, 16, 3, and 6. Again, going down the columns. In this case, A and B are the same length, so there's no repetition necessary there. And then the third example that was on the screen was A is 5 and 9, B is -2, and so what we need to do is we need to repeat B as many times as necessary to fill it out. And so the product is going to be -10 and -18 for that one. Okay, so clearly we're going to need a loop that goes through the entire A array, because that's going to be the longer one. So it needs to go through the entire A array. But how do we do this? How do we repeat this? And so one thing you might think of is, why don't we make a new array called like B2 or something like that, and then figure out how to actually copy the elements into this new array so that they look like this. And then we can just simply run our loop across A. Now that A and B2 are the same length, we can just run our loop across them like we did in the previous problem and just multiply them down. But there's a fancier way to do this, and that is what we need to do is, let's write down the index numbers, is we're going to write a loop that goes again from 0 to the length of the array, so in this case 0 through 4. But what I want to do is figure out which of these 2 elements to look at when I'm looking at the ith element. So let me put down some numbers here. So if I'm looking at the 0th element of A, I obviously want to be looking at the 0th element of B. Right? And if I'm looking at the number 1 element of A, I want to be looking at the number 1 element of B. And if I'm looking at the number 2 element of A, I want to be looking at the number 0 element of B. And then same thing goes across. So it goes 0, 1, 0, 1, 0, 1. So what I need is some way to calculate this number from this one. And I think what we need to do is run some more examples. Let's try A is 1, 2, 3, 4, 5, 6, 7. I'm going to go longer. And let's say B is 8, 6, 1. Okay? So I'm going to go 8, 6, 1, and 8 again. So if I go with the index numbers, 0, 1, 2, 3, 4, 5, 6. And the index numbers here are 0, 1, 2, 0, 1, 2, 0. Okay, do you see that? Okay, these correspond very nicely. When you go to 3 here, you loop back to 0. When we go to 4, you loop back to 1. And we go to 5, you go to 2. And we go to 6, you loop back again to 0. Okay, so whenever you see this kind of repetition like this, I want you to think of more like a clock. It goes around this way, right? Clock, it goes, 12, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 1, 2, 3, 4, 5. So it keeps going around and around and around. So when you increment up to 12, you increment 1 past 12, you actually go to 1, then you go to 2, and you go all the way around again, and then 12 becomes 1 again. So picture that we've essentially got a, let's see, how can I draw this picture? We've got kind of a ring that goes 0, 1, 2, around like this. Like that. So that's our little inner B ring, and then our outer ring is 0, 1, 2, 3, 4, 5, 6. Right? So our A is going from 0 to 6, and our B is going 0, 1, 2, 0, 1, 2, 0, 1, 2. And so hopefully you can see from this picture that these numbers differ by 3, these numbers differ by 3, and these numbers differ by 3. And in fact, this number and this number are obviously the same. This number and this number, obviously this is 3 more. Let's see, what's the relationship I'm looking for here? This is multiples of 3, 0, 3, 6. The next one would be 9. This is multiples of 3 plus 1. So it's 1 and 4. The next one would be 7. This is multiples of 3 plus 2. So it goes 2, 5. The next one would be 8. And then we come back over here for 9. So it goes 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, and so forth. So what we want to find is the relationship between these numbers. Okay, so the first thing to note here is the length of B is 3. And that's the same as this number here. So somehow that's going to tie into this. So what if we take this number, like 4, and we go modulo 3. So 4 mod 3 is 1, right? If we take 4, divide it by 3, we get a remainder of 1. If we take 5 and do a modulo 3, we get 2. If we do 6 modulo 3, we get 0. That's the relationship we want. So it's basically going to be I mod B dot length. Sorry, went behind my head there. B dot length. So whatever the ith element of A is, if we do a modulo the length of B, that'll give us the index number into B, and it'll be exactly the right one. So that's right there. That's what we want to do to calculate which element of B corresponds to the element of A. All right, so let's give it a try. So we're going to need to create a new array that's the same length as A. So let's call this int array prod equals new int array, and its length is going to be the same as A's length. And then we're going to run our loop for int I equals 0, I is less than A dot length, I plus plus, and then the ith element of the product array is going to be the ith element of the A array times, and this is our calculation from the other screen, I modulo B dot length. So we're going to look at the ith element of A and then calculate which element of B we want to look at. And by using modulo, it's going to make it cycle around and around quicker than the outer loop is running. And then we're going to return that array. So let's see if it works. Oh, missing my brace again. There we go. We got all greens. Excellent. All right, so this is an example here of we are processing one array and we're processing another array kind of at a different rate. So we are calculating which element to look at based upon the element number of the outer array, or the outer loop. All right, so this is kind of a fancy technique for lining up two arrays that are not quite the same length. Okay, so those are actually all the examples that I had for you today. I hope you got to see here an example of how to create an array, and that's right here. How to write a loop that goes from beginning to end of the array, and you're going to use the length of the array in order to figure out when to stop running your loop. And then inside the body here, you do some kind of calculation on each element of the array. And then when you're all done, you return the new array, or you return the sum or the accumulator, or whatever it is that you're trying to accomplish in your program. Okay, so hopefully this will give you a good preview of what we're doing in the coming week in our class. If you've got any questions, go ahead and post them in the chat right now. I'll stick around in the chat for a few minutes. But otherwise, I will see you all later, and I hope this helped give you a good refresher if you have seen arrays before, or gives you a good introduction to arrays and loops if you haven't seen them before. Thanks for watching. Bye-bye.